Hi everyone, this is Ansky, and today we're going to be covering our second session in programming in Java. So we will today take a look at strings, but we won't cover them extensively. There's an important reason why that is, and I'll touch upon it in just a second. So strings are effectively a bunch of letters, bunch of characters that you already know, data type a character. So for example, if it's A, B, and whatever, and we put them into sentences. So imagine as we take letters from the alphabet, we put them together and we create a sentence from that, of our word effectively, right? So this is effectively what a string is. Now, strings are immutable, which means once they are created, we cannot change them. And this is an important part. So for example, if you create a word, let's say, for example, PlayStation, and then we just want to create another word, or we would like to change that word to be just saying station, we cannot do that. We have to effectively create a new variable that will be able just to say station. Now, reason why I don't want to touch upon effectively explain the entire strings today, because there is a way to change the strings later on. So there's something called StringBuffer and StringBuilder, which we'll touch upon a bit later on, because I kind of firstly want to cover objects and methods and classes before we jump into how the StringBuilder or StringBuffer works. But those effectively allow us to create and modify the strings, already existing strings. Now, obviously, this is your second session. I do not want to throw this on you yet and get so much into depth on this. So today we'll be effectively talking about very basics. We'll skip effectively slides because there's not much to say, but we will talk about how the strings are created, how can we use them, and also one of the most important thing as well. We will talk about the pool. So Java has something called a pool, right? That's kind of how we create it. Now I'm gonna try to effectively explain it in the easiest way. Pool is effectively where objects, or effectively in this case our words, would be stored. So imagine you create a variable a saying abba, so ABBA, right? Now what this happened is this would be thrown into this pool and then effectively have this hashcode. So hashcode effectively just reference to that word. If you were to create a variable b, and b would also have name abba. Now what happens, this is where the Java is really cool. So in order to kind of minimize the amount of memory that we use, Java would effectively assign the same reference number to the b value. So it would effectively, whenever we would call that value, those effectively will be in the same pool, okay? And for this, it's a kind of an important thing because we kind of have to remember that whenever, for example, we check values, when we're gonna go to arithmetics, we can check whether 5 is equal to 2. But in this case, if we're gonna say that A is equal to B, it's not gonna work. We have to do A is equal B. And this is exactly what we kind of touch upon today as well. It will make more sense soon, okay? So we'll kind of go through those very quickly as well during our class. So let me, instead of just talking, let me jump into my IDE and let's start covering it. So see you soon.
We are now in our IDE. This is our script from the last time. We are going to delete this in a second. We will not use it for now, but I kind of want to keep it for just a second. I mean, the main part I want to keep is just effectively this. As you remember, we were covering last time, so we always put the data type first. Then we're gonna put our variable name, and then we can initialize it by putting equal sign and giving it a value. So what is supposed to store? This is the same case with a string. So if I type string, firstly what I want you to do is I want you to realize that there is a lot of options that comes up. Now, string is an object in Java, okay? It's not effectively, it is a non-primitive data type. So it comes from java.lang, and then effectively this is the reason why this starts with a capital letter and not with a small letter. After that, we can just give it a name. So let's give it a name Abra, and then we can initialize it But one of the things that I want you to realize and remember, this is a very important thing. Characters comes with a singular quotes, so like this, but strings comes with speech marks, so double quotes, so like this. So let's just name it Abra, and then just put semicolon. So this would be effectively our string. We can delete this one, this no longer matters. So if I right now try to print Abra, this will effectively print Abra. Perfect. Right. So let's do the same thing with create a second string, and let's call it BAM. And let's just make it Cadabra. I just want to kind of reason why we call it BAM is just so you can see that you can have effectively different written like anything over here and then whatever you want to here. So you can have a different variable name. Now, if I'm just gonna print BAM like this, it will allow us to print Cadabra. Perfect. Now, let's kind of touch quickly upon what can we do with the strings. So first see, as I said to you, remember, you cannot effectively really change the strings, but kind of Java helps us with it. So it kind of redoes the entire string. So if I were to type right now Abra and then just put anything else, so anything else like this, or let's just put it Cadabra, because why not? Okay. If I'm gonna run this and I'm gonna print Abra like this, what you're gonna see first is we're gonna have Cadabra as well. Okay, so we can change the strings like this when it comes in Java. So the next thing that we kind of have to understand over here, so we're gonna touch upon why are those objects. The reason why is because they have lots of methods. So if I right now type Abra, if I put a dot, this will give us lots of different methods. Do you see M next to it? M just stands for a method. Now this gives us the name of the method, and then at the right side it gives us what does it effectively return. Now, reason why we kind of care about this right now, we're gonna touch upon this way in the future, and you'll be able to do it by yourself. But for now, let's just take care of the hash code. So if I take hashcode, by the way, if you wanted to print this one as well, you can just type south at the end like this, with a dot afterwards, and it will change it. So if I write now, I'm gonna delete this for now. Actually, no what? I'll just keep it, but I'll comment this one out. So if I run this, it's gonna give me that this is just the value, which is 2987536. This is a reference, effectively, we can kind of call it. And it's effectively a hash code. If I right now would to do the same thing with BAM and run it, you're gonna realize once again, those are two different hash codes. They have totally two different values, which means if I were to check them both, they will not be equal, right? So in this case, we can just check by Abra equals BAM, right? One of the things that we have to know in Java is singular equal mark. It means that we are assigning a value. Equals means is equal to. So we're checking whether two values that we're passing are the same. And we'll touch this more upon on the next session when we're going to be covering a bit of maths and a bit of arithmetics. Probably session after that, because we need to firstly cover methods. So if I run this right now, it's going to tell me, it's going to return true or false. So it's going to return you a boolean. So we're printing both of the hash codes. So this is the both of the hash codes that we printed. As you can see, they do not change. And then we're printing a boolean saying false or true. So is this equal to this is equal to true, or is this equal to this is equal to false? Now, one of the things I need to instantly mention, we do not want to check strings like this. We want to use something called, if I remove this, if you press dot, you have something called equals, and you can see it takes an object. If you remember, string is an object. So we can just click this and we can put BAM in there. This obviously will still return for us that it's false because both of them are different. However, let me show you now something really cool. If I were to type Abra over here, so Abra and BAM would both return Abra. If I run this, they will both come up with the same value. This is the thing that I was talking about pooling. So Java effectively checks and takes two different strings, and because they have the same value, they throw them into the pool and they both get the same reference. So we can effectively find them easily. This stores the memory because now instead, minimize the amount of memory usage. The reason for that is because now instead of storing two variables, we're no longer storing two variables with two different abras. We're storing only one variable and references, abra and bam references the one stored information, which is called abra string. So when we run this and we check abra is equal to bam, it will come up as true. But now, there's one thing that I want to show you, and this is the incredibly important part. If I were to change this to a capital letter and run this, what you realize is they no longer the same. So Java is case sensitive. So this is one of the important things you kind of have to know about Java. So they no longer same, even though they exactly the same words. So what we tend to do is we can, with Java, so if I'm just gonna make some space, if I type Abra, I can do something, as you can see, to lowercase. So this is the one we are interested in. We can do to lowercase or we can do to uppercase. Those two allow us to either print it as a lowercase or capitalcase to uppercase, like this. So if I run this right now, what you'll see is Abra and Abra. So this is a lowercase and this is a capital case. However, our value, the hash code, does not change. The reason for that is because when we initialize it, we have a different case sensitivity, and for this reason, the word is different. So now, what if I do, for example, like this? So equals to BAM to lowercase, right? So in this case, BAM will also be Abra and it will be small. They are totally two different hash codes. But if I run this, what you'll see actually, so I'll just keep the hash code so you can see they are totally different hash codes, but it will become true. So what equals does is equals check every character inside our string. So if they all are like exactly the same, whether they are small or anything like this, it will tell us that it's true, it's the same word. However, and this is the fun part when it begins, and this is reason why I was telling you that equals should always be used with strings. If I to type Abra is equals BAM to lowercase and run this, this will tell us that it's false. The reason for that is because equals does not check each character, it does not check the string itself. It checks the hash codes, whether the hash codes are equal. So because they are completely different, even if the BAM to lowercase is the same as Abra, they still have different hash codes. And because of this, it gives us false. So this is one of the common mistakes that a lot of programmers do. And also another question on interview, can you use equals with a strings? You technically can, but practically they're not really good. They can cause a lot of issues like this. The reason for that is because they follow hash codes and not the string itself. Okay, so now we have this out of the way. Let's do some cool things with strings. What can we do? So let's delete those strings for now, and let's make a new string name, and let's maybe call it John. And let's create the second, and for example, surname, and let's call it Lake, because why not? Now, I could effectively do name plus equals Lake. So firstly, we can do it this way, and then I can print the name. And if I run this, what you will see is that this was added. Plus equals effectively just stands for take the name, whatever the name is, and then add to it. So this Lake. Now, one of the things I need you to kind of bear in mind, I want you as a programmer from now on, I don't want you to see the name. I want you to see that variable name, what does it represent? So when you take a look at it, John is equal to John plus Lake. We can add them mathematically. So effectively those two just gonna be bunched together. But as you can see, it prints without a space. We could just add an empty space like this, like that. Okay, so we just effectively just open a new string, we just add a space and we print it. So if we run this right now, it will be working perfectly. Now, not every single language allows us to do this. Because if you remember, like I told you, strings are immutable, they cannot be changed. Our Java actually helps us to do this and allows us to do this, but that's one of the very few languages that effectively helps us with this. Okay, another thing. So we kind of covered something called concatenation. What this effectively just means you add those two together. Yes. Now, that's a cool thing, right? Because what we can do right now is we could do in system.out println. So when we print to the console, we instead of just writing this as a name, we could effectively do name plus surname. And we could run this as well. So name is equal to John and surname is equal to Lake, and it brings John Lake. We can also add empty space like this and add and run it. So now concatenation effectively allows us to add those two strings together and print them out. This is really useful because what we can go further with this. We can write the name given was, and then you could put make an empty space over here, so we don't have to do plus an empty space, and then we can write name plus empty space, and then plus surname, and then we can do plus even, and because now we don't want space, we just want to put a dot, not comma, dot. Right, so if we right now print this one out, it's gonna say the name given was John Lake, and then full stop. And this is one of the important things that you kind of gonna have to understand as well and play around with it, because as we're gonna start going more into creating variables, when we're gonna have to print, we're gonna have to be able to print them using concatenation, so using the strings and sometimes maybe the values. So for example, an integer should be printed over here or something. Actually, let's do this. So let's do int age is equal to 25 as an example, and then and then let's close this for a second and then just put age years old, and let's run this. So now if you're gonna run this, it's gonna say the name given was John Lake and has 25 years old. Obviously we can make a space between years old, so as you can see also I just made a space between Y and the start, so this is gonna also include this space, and if I run this right now, it also will give us some space over here and say N has 25 years old. So this is one of the strengths, and this is kind of what I want you to take a look at and play around with it as well. This is gonna be incredibly important for us as we kind of gonna go further down the line. Especially for the next session. So now one of the things that I want you to do, and this is kind of your challenge, I want you to create a bunch of different names, bunch of different surnames. Think of any modules or any class that you liked back in the day at your school. And then I want you to create few console prints. So system.out.println effectively is just a console print. So you print to the console and have multiple of those like this. And then saying, for example, the name of the student was this and the favorite class was this, and have multiple of those. And maybe if you feel like a bit going further down to that, I want you to start comparing two strings together. So I want you to play around with name one, for example. So if I do this, name one, string name one is equal to, for example, Alex, like this. And then string name two is equal to Alex, and then maybe string3 is equal to Alex, like this, and maybe a different variations of this. And then I want you to try to compare all of those, that all of them will come as true. So whenever you compare whether they all equal to each other, it should come up as true. Additional thing, I want you to kind of play around and see if, for example, you were to create, let's say, another string, and let's say hash1 and then any value, maybe like this. What do you have to create as a hash2 to have the same hash code as this one? And how do you check whether they equal, the hash code is the same? Okay, so this is a kind of a challenge, because what you're gonna have to do, if I'm just gonna put whatever value, and I'm gonna kind of help you here. So the way to check whether the hash codes would be effectively the same, you can, if you remember, you can take hash1 is equal to hash2 and check whether those hash codes are gonna be exactly the same. If I run this right now, it's gonna give me false. But if the values are correct, it should tell me true. Okay, so take a look at it, play around with it, have fun, and thank you for watching. And hopefully that's very helpful. Leave me some comments if you have some struggles, if you need some help, or if there's something I could improve. Hopefully you can also subscribe and like in case if you wanna move on with our journey and continue with our next videos. And I'll see you soon. Bye bye.